The history of the formation of our solar system. It all began with the brightest and most powerful explosion in the history of the entire universe. The origin of everything. The Big Bang occurred 13.8 billion years ago, and fundamental particles began to spread out in multiple directions, gradually cooling into matter. This matter eventually formed the universe as we know it. All galaxies, black holes, stars, planets, asteroids, and even you and me. Yes, all of us were created from a collection of particles that emerged from the Big Bang. Let's fast forward to 4.6 billion years ago. This was the time of the nebula that would become our solar system. At first, it was just a cloud of cosmic dust, rocks, and icy blocks. Shockwaves from supernova and surrounding regions began pushing the matter toward a single center, much like waves in the sea. Eventually, all the material coalesced around a central point, forming a massive, eroded rock. It pulled in more debris, compressing itself until nuclear reactions ignited. With a bit more pressure, light appeared. This was the birth of our sun, about 4.59 billion years ago. The first giant gas planets formed, including Jupiter, Saturn, Uranus, and Neptune. These planets were composed entirely of gas and had no solid surface. Some suggest there was a fifth giant gas planet, but it was ejected from the solar system. In the next 100,000 years, a solar nebula appeared, a young, bright star at the center, surrounded by a disk of gas and dust, leftover material from the initial nebula. This was like a boiling cosmic soup, with materials swirling around the sun, colliding and forming the rest of the planets and moons in the solar system. As the dust settled, Mercury, Venus, Earth, Mars, the asteroid belt, Jupiter, Saturn, Uranus, and Neptune became visible, about 4.5 billion years ago. While Earth was still a molten rock, a Mars-sized protoplanet called Theia appeared near it. Theia collided with Earth, breaking apart and ejecting debris that eventually coalesced to form the Moon. Between 4.1 and 3.8 billion years ago, the late heavy bombardment period occurred. Remaining debris not forming planets continued moving through the solar system, crashing into newly formed planets. This event created many craters on Mercury and the Moon. Scientists have found fossils of the oldest life forms on Earth, dating back about 3.8 billion years, coinciding with the end of the heavy bombardment and the start of even 3 billion years ago. Strong solar winds and frequent asteroid impacts stripped Mars of its atmosphere. Without it, life could no longer emerge there, although some scientists believe Mars may once have been habitable. 2.5 billion years ago, the Great Oxidation Event occurred on Earth. Some organisms evolved to harness sunlight and produce oxygen. Gradually, our atmosphere filled with oxygen, wiping out many earlier life forms, but paving the way for new ones. 100 million years ago, one of Saturn's moons was destroyed, either by a collision with a large asteroid or by Saturn itself. The debris formed icy rocks and dust, which continue orbiting Saturn today as its inner rings. 66 million years ago, Earth was hit by an asteroid the size of Manhattan. The impact was visible from space, and clouds of dust blocked sunlight. This event caused the extinction of most living species, including dinosaurs, 70,000 years ago. At the edge of the solar system, the star passed by, leaving a region of asteroid 56 years ago. Solar system looks much like it did billions of years ago, though humans have added artificial satellites, the International Space Station, and exploration probes to Mars. Looking ahead, in the coming decades, Earth will regularly send spacecraft to Mars every 2 years, when the planets are close 100,000 years from now. The wandering star will return, disturbing the Oort cloud again and sending objects toward the inner solar system. Over the next 9 million years, it will approach a distance of about 52,000 Earth-Sun distances. 10 million years from now, Mars, moon, Phobos, will slowly move closer. Gravitational interactions will tear it apart, with some debris falling to Mars and the rest forming rings like Saturn's. The future of the solar system depends on us to return billion years. Its brightness will increase by 10% as it burns more hydrogen fuel and becomes hotter. In 1 billion years, Earth's temperature will rise so much that liquid water will no longer exist. Oceans will evaporate, causing a runaway greenhouse effect, and life on Earth will become impossible. At that time, humans will travel to Mars, which will become the new habitable zone in the solar system. Beneath its ice layers, Mars will have melted ground, generating a greenhouse effect. Conditions there will be suitable for humans. 3.5 billion years later, Earth will resemble modern Venus, desolate and dominated by volcanoes and dry riverbeds. 7.7 billion years from now, the sun's hot core will trigger nuclear reactions in its outer layers, and the sun will expand into a red giant that will grow 250 times mass, weakening frenetically, heat-loving its gravitational pull, and the orbits of the planets will widen. Earth may survive as the closest remaining planet to the sun. Mars will become too hot, prompting another migration to Titan, Saturn's moon, which has liquid water. Currently, Titan has half its fuel. It will shrink, still remaining 11 times larger than today. In 100 million years, it will expand into a red giant one final time. Over the next 30 million years, the sun will emit strong solar winds, shedding most of its outer material and forming a beautiful planetary nebula. With most of its mass lost, it can no longer hold planets in orbit, causing chaos. Some planets would be ejected, others may collide, and some will survive in wider orbits. In 75,000 years, only a white dwarf, roughly Earth-sized, will remain at the center of the solar system. The sun will gradually cool until it disappears completely. Any remaining planets will be cold, dark, and unable to support life. From its birth to its end, the entire history of the solar system spans approximately 12.4 billion years.